Good day and God bless everyone. I hope everybody is doing fine and you are now answering our learn activities in General Physics 2. Before anything else, I want to check your attendance for this video. All you have to do is just comment or give your class section and name on the comment part of this site. We start our lesson, let us have some sort of recap about the previous lesson which are related in the lesson that we're going to tackle today. For our review or recap, we will play an activity entitled Fact or Bluff. In this activity, you will identify whether the given statement is fact or true, or it is bluff or not true, or false rather. Are you ready, class? Here is the first statement. Current refers to the flow of the electron in each point. Is it a fact or bluff? Again, will you pause the video for a while and then play it when you know the answer? Okay, for this statement, the answer is fact. Okay, it is true that the current refers to the flow of the electron. So that is the rate of the electron flowing in a certain wire. So that is what we call current. So the statement is fact. Okay, here is the second one. Resistance is the ability of the resistor to resist the flow of current, and it can be represented by amperes. Is it a fact or bluff? Again, pause the video for a while and then play it when you have the answer on your mind. Okay, for this statement, the answer is bluff. Why it is bluff? So as you can see in the statement, resistance is the ability of the resistor to resist the flow of current. Yes, it is true. It is the definition of resistance. But the follow-up sentence or statement says that it can be represented by amperes. So it is bluff because you know that amperes is used for the unit of current, and resistance use ohm or ohms for resistance. So this one makes the statement false. So the answer is bluff. Okay, let's move to the third one. Voltage is not necessary for the current to flow. Is it a fact or bluff? Again, will you pause the video for a while and play when you have the answer? Okay, for this statement, the answer is bluff. Why it is bluff? Because it says that voltage is not necessary. So we all know that without the voltage, there will be no current flow. So this is bluff. So voltage is very important for the current to flow. Okay, so it seems that we are done with our review and we already mentioned those important um, background information that are necessary for today's lesson. We can now proceed with our new. But before that, let us have some sort of activity. And this activity is called picture analysis. So in this activity, I show you a picture and all you have to do is to build the concept out of this picture analysis. Are you ready, class? Here is the first picture. Again, pause the video for 1 to 2 minutes and play it when you have the concept on your mind. Okay, now here is the question based on the picture. What is the relationship between the three variables in the given picture? Okay, will you pause the video and tell the answer for yourself? And then let's see if you have the same answer with me. Okay, so the answer is voltage helps the ampere to flow while the ohm prevents the two. So as you can see in the picture, if we will put motion in this picture, it will goes like this. So we can see in the picture that the voltage or V pushes the A or the amperes. And then this 2 is what? Prevent by the ohms. So it can't move easily because the ohms prevent the motion of the ampere, even though the voltage pushes the ampere. So therefore, based on the picture, we can say that the ampere and voltage are directly proportional to one another, and both inversely proportional to ohms or resistance. This idea has something to do with our lesson for today, which is Ohm's Law. But before we start, here is the objective of our lesson. At the end of the lesson, 100% of the students shall be able to attain at least 85% level of proficiency to first, identify the relationship of voltage, current, and resistance. Solve for each variables in Ohm's law. And third, recognize the importance of understanding the concept of Ohm's law. Again, what is Ohm's law? Ohm's law, named after Mr. Ohm, defines the relationship between power, current, resistance, and voltage. Ohm's law states that the electric current I is proportional to the voltage and inversely proportional to resistance. For better understanding, let us chop the information stated by the Ohm's law. Based on this statement, current I is directly proportional to the voltage, and current and voltage are both inversely proportional to the resistance. Based on the statement that I have shown a while ago, here is my question. What will be the equation for Ohm's law? If you know that current is directly proportional to voltage and current and voltage are both inversely proportional to resistance, what will be the equation? Okay, will you pause the video for a while and think what will be the equation? Then if you know the answer, play the video. Okay, for the Ohm's law, the equation will be I is equal to B over R, or current is equal to voltage over R. As you can see in this equation, the current is directly proportional to B but inversely proportional to the resistance. So this is the equation that we're going to use when we are solving problem regarding Ohm's law. Okay. So as you can see in this picture, we have three equations. So these three equations came from the first equation that I have shown a while ago. So we can use any of this equation. We can use the first one, which is B is equal to I multiplied by R. Or we can use the second one, which is I current is equal to B over R, or that is the first equation. Or we can use this one, R is equal to B over I. So it depends on what is the missing on the given problem. So here's the following equation that derived from the first equation. Now, we can now proceed with the sample problem, where to apply the Ohm's law. Are you ready, class, for the sample problem? Okay, let's start. So here's the first problem. Find the resistance of an electrical circuit that has a voltage supply of 10 volts and a current of 0.005 ampere. To solve this problem, we will use GRESA format, which is G for given, R for required, E for equation, S for solution, A for answer. So, like what I said in your group chat or messages or in our GC, always use this format because using the GRESA format, you will identify first the given, the required, the equation or the formula to use, and then you substitute the answer or the equation from the given, and then you can easily find the correct answer. Okay, let's start. For this problem, we have the given D, which is 10 volts, and the given A, or ampere. The value for current is 0.005 ampere, and the required is the resistance. As you can see in the problem, it says that we need to find the resistance of an electrical circuit. For this problem, we will use the equation R is equal to B over I, since we need to find the value of the resistance. So for our solution, we just substitute the given to the equation. So it will look like this. R is equal to 10 volts over 0.005 ampere. So if we will divide this, the answer will be 2000 ohms. So this is the answer. So as simple as that. So it is very helpful to use the Ohm's law in finding variables regarding resistance, voltage, and ampere. Okay, for this, now let's move to the second problem. This time, you and I will solve the problem. So I expect that you have your scratch paper with you in solving this problem. Okay, let's start. An electric device has a resistance of 20 ohms and a current of 15 ampere. What is the voltage across the device? So again, we will use the GRESA format. So let us find first the given, required, equation, solution, answer. For this problem, the given will be R, which is 20 ohms, the resistance, and A, 15 amperes, and the required is voltage. As you can see in the question, what is the voltage across the device? And for this, since we need to find the value of the voltage and our given is the resistance and the ampere, we can use the formula B is equal to I over R. So for our solution, B is equal to 15 amperes multiplied by the 20 ohms. So the answer will be 300 volts. As easy as that. So it is very easy. I hope that you have the same answer with me. Okay, let's proceed with the third one. Class, here is the third problem. This time, you will be the one to solve this. Just pause the video and solve the problem. Then, play it when you have your solution and answer. Okay, you may start now. Okay, if you already have your solution and answer, let us solve and check if you are correct. Okay, let us read first the problem. In a circuit, the potential drop across the 10 kilo ohms resistor is 100 volts. What is the current through the resistor? So again, let us find the given, the required, the equation, the solution, and the answer. For this problem, we have the given R, or the resistance, which is 10 kilo ohms. So let us convert it already to ohms. So it is equivalent to 1000 ohms. And then we already have the given for our volts, or voltage rather, which is 100 volts. So obviously, Based on the problem, the question is what is the current? So we need to find the value of the current. So that is the required current. So since we already have the value of the R and the value of the voltage, and the missing one is I, obviously we will use the equation I is equal to B over R. So the solution will be I is equal to 100 volts over 10,000 ohms. So the answer will be 0.01 ampere. So that is the final answer. So I hope you have the same answer with me. So if you have the same answer, it is good. Then if you got the wrong answer, still you need to go back to the previous um, session of this video so that you may be able to see what is the proper way of solving and what is the correct equation to be used. Okay. Since we're done with the solving problem, now let's move to the application of the Ohm's law. Ohm's law is fundamental law of electrical engineering. It has a large number of practical application in almost all electrical circuits and electronic components. Here are some application of Ohm's law in our daily life that we usually come across in our real life. So the first one is the power supplied to electrical heater. So for example, so we have the electrical heater. So electrical heater is commonly used appliances in winter. So in other country they use this, especially those who have winter season. So provided with the resistance of the heater of the coil and applied voltage, we can calculate the power supplied to this heater. So this power can be multiplied with time, then we can calculate the electricity bill at our premises. So you will be able to know what is the contribution of the electrical bill, knowing or using the Ohm's law. If you know the value of the resistance of the coil and its voltage. Next is selection of fuses. So fuses and circuit breaker are the protection components which connects in series with the electronic devices. Fuses or CBs are rated in amperes. So you have the value of the amperes. The current rating of the fuse is calculated using the Ohm's law. So that is another application of the Ohm's law. By this, you can determine the size of the fuses to use. So we can able to know the size of the fuses to use, especially those electrical engineer, they use this Ohm's law to identify the value or the size of the fuses. So Ohm's law can also be used in designing of electronic devices. The electronic devices such as laptop and mobile phones require a DC power supply with a specific current rating. Typical mobile phone batteries require 0.7 to 1 ampere, and a resistor is used to control the rate of the current flowing through these components. The Ohm's law in this situation can be used to calculate the rating of the current, which should be used in typical circuits. So it is very important to find the value of the current. So in designing electronic devices. So that is also the application of the Ohm's law in designing the electronic device. Next is sizing of the resistor in consumer electronics. So the electronic components such as the normal power supply, the interruptible supplies, iron, kettle, television, and similar components use a lot of resistor for their control purposes. The wattage sizing of any resistor should be carefully selected. So it is very important that we carefully selected the wattage or sizing of the resistor. So another, by the use of the Ohm's law, we can use to find the size of the resistor. No? So we can use the formula P is equal to B multiplied by I. So that is also the application of the Ohm's law. So we're done with the application. Now let us summarize our lesson for you to have a recap regarding our lesson before we proceed with the evaluation. So are you ready? Here's the summary. So Ohm's law again, the basic law concerning the flow of electricity. So that is Ohm's law. The Ohm's law came after Mr. Ohm defines the relationship between power, current, resistance, and voltage. The Ohm's law states that when an electrical potential or the voltage creates a flow of electricity or the current and the electrical resistance of the circuit are proportional to the voltage. So that is the relationship between the three. Current and voltage are directly proportional, but these two are inversely proportional with the resistance. Next is, in mathematical terms, the current I is equal to B over R, where B is the voltage and I is the current, and R is the resistance. So that is the summary of our lesson. So for you to see where those content in this video came from, so here are the resources of those information that I posted in this video. You may browse them for your references. Now let us proceed with the evaluation for me to know whether you acquired the knowledge that I want you to learn. So let's start. So again, use your knowledge about the Ohm's law to answer the following question. Question number 1. If the voltage across a circuit is quadrupled, then the current through the circuit would be. Number 2. If the resistance of a circuit were tripled, then the current through the circuit would be blank. Okay, solve the given problems. So I have here two problems. All you have to do is to solve them. Number 1, an electrical device with a resistance of 3.0 ohms will allow a current of 4.0 amps to flow through it if a voltage drop off, so you have to find the voltage, is impressed across the device. Last one. So cite importance or application of the Ohm's law in our real life. So those are the problems. So all you have to do is to send your answer in PDF form on our Google Classroom. So I provided a certain folder where to send the answer for this video lesson. Thank you and God bless everyone. Always keep safe.